Hello, good evening. Today we are going to talk about recent advancements in smart grid technology. The person who is talking, Maria Jose Castillo Monroy, and my um, equipment, Juan Diego Cruz Salazar. So the topic of these presentations are going to be like the introduction. We are going to talk about the authors of the paper and a little abstract of what the papers talk about. We are going to talk of theoretical frameworks, specifically the concept of smart grid, new technologies and measures, and DC-DC converts. After that, we are going to see the view of futures, investment in a smart grid, future stress, and smart grid recent trends. And the last one is going to be the conclusions. We are going to talk about the reference that we use and the conclusions that the paper has. So for the abstract, with the advances of technology, there is an immense increase in demand of electrical energy that has not only become challenged in the production, but also in the distribution. So this rising demand is growing the complexity of power grids by increasing requirements of greater reliability, efficiency, security, and environmental. The traditional power grids are focused only in some of the basic functions like generation, distribution, control of electricity. The electricity grids in present are unreliable and had high transmission losses, poor power quality, prone to brownouts and blackouts. Supply inequality electricity, discussing the integration of distribution energy sources. On the other hand, smart grid technology has a way of solution, better generation of electricity power, and better efficient, and a better way to make a transmission and distribution of the power. Do it is more versatile and more easy to install because it requires less spaces in comparison of traditional power grids. Next one, please. The author of this paper are Osama Mahed. Mr. Boot is graduated as electrical engineer from the University of Umhat. He also did his master in this university. He joined the Department of Electrical Engineer at the year 2015. At the present, he is working as a lecturer in the same institution. He have different foreign trainers, like a PhD studies from the University of Malaya. The other author are Mohammed Sularkand. He graduated at the same university, University of Puhat, as an electrical engineer. He did a master from Lanori University Managed in Science. He joined the Department of Electrical Engineer in 2018. And the last one is Talat Mahedbur. Talat is graduated as electrical engineer from University of Puhat, and currently he is completing his master in a sustainable energy system from the University of Freiburg, Germany. Okay, for the theoretical framework, we are going to explain the concept of a smart grid. First, the definition. So it's complicated to give a specific definition for this concept. So for a better comprehension of this paper, we are going to say that it's a system of power electronics for a development of technology for the generation, production, distribution, and control of energy and electrical energy. Another way to say it, smart grid is a concept for the conventional grid with some less unautomatized features, which make them, like we said before, more reliable and sustainable. So, to talk about the designer, to understand what the design of a smart grid is, we have to compare it with a traditional power grid, like we can see in the table that it's in the right. The smart grid have two-way real-time communication. Conventional grid, only one way. Smart distribution have a distribution system of power generation. Conventionals have a centralized for power generation. A conventional have a radial network. In our hand, a smart grid have an interconnected network. Conventional grids have a small quality of basic sensors, and a smart grid have a lot of number of sensors that are involved. We have in the smart grid digital operation, automatic control and monitor, and in the conventional grid mechanical operation and manual control monitor. We have in the smart grid wide range of control, but in the conventional grid we have a limit control. So in conclusion, we can say that the design of a smart grid is more flexible and it helps us to finalize some objective. So we are going to talk about the characteristics of a smart grid. So a smart grid, we can say that it's like we said before, is a way to solution a better generation of electricity power. We can make better the efficiency. We can make it more versatile and more easy to install it because it requires less space, like we did before. The design is aligned for great observability, great controllability for iSense, enhance performance and security of power systems. And in economic aspects, is more viable because maintain and plans is more easy. We should this is why we can consider it that a smart grid technology can be used as a microgrid level, which eventually it's connect with others microgrid level to form a large network of a smart grid. This smart grid have a huge potential that could be the solution of a reliable of power transmission and distribution of development countries with lack of infrastructure. As we can see in the picture, the overall of the smart grid architecture, we have the security, the electric storages, the sustainability, the communication, the integration microgrids, the reliability, and the demand responses. We are going to talk about only a few of them. First one, the reliability. We can talk about how successful is a grid system. It depends of the upon of customers, which is measured and reliable grids. We have with the smart grid a lot of potential in this area because it allows of self-helping the systems, and they have the capacity of to monitor and store the data and estimate its service reliability. Uh, if we talk about security, this we have some problems with the smart grid because like everything is connected. According to the Electrical Power Rights Institute, the cybersecurity of these systems is one of the biggest uses. Then we are going to talk about the demand responses.
Okay, for demand response, smart grids provides the demand side or uses to interact with the grid by using two ways communication ability. It provides a chance for the consumer to use the electrical power in an economical way. It will not only help for increasing efficiency at demand side but also at the distribute end. It helps grid to reduce demand and stress during peak period by reducing of shifting power requirement to alternative and self-healing which use network data in real time to record its characteristics. With this remotely, it will be possible in isolate the place where the network has problems and can be solved. The smart grid then has the ability for the self-healing, real-time monitoring and reaction problem anticipation and rapid isolation. So, new technologies and research. A number of ongoing research activities are being made for the advancement of the smart grid to make it more reliable and sustainable for the modern needs. These researches are focused on different technologies. It is difficult to cover all the research and advances, but this section includes some of the prominent and latest technologies and research activities associated with a smart grid specifics, we can talk about four areas of development: energy management systems, Internet of Things, smart grids with electric vehicles, and big data. So, the paper we don't talk about DC-DC converters, but for this majority, it's a very important topic. So we're going to make it a little introduction about this. In many industrial applications, it is required to convert a fixed voltage DC source into a variable voltage DC source. A DC-DC converts directly from DC to DC, and this is simply known as a DC converter. A DC converter can be considered as DC equivalent to an AC transformer with a continuously variable turn radio. Like a transformer, it can be used to step down or step up a DC voltage source. This type of converter can produce a fixed or variable DC output voltage from a fixed or variable DC voltage as shown in the figure. The output voltage and we input current should ideally be poor DC, but the output voltage and the input current is a practical DC-DC converter containing harmonics or ripples. An example of this type of circuit is that a step down, as we can see in the picture, output voltage can be changed.
Okay, let's talk about a view of futures. What is the investment in a smart grid around the countries? So different countries in the world have stepped forward of the era in the smart grid. Many of them are working on a pilot project of this topic. Some of them are making testings and research. So we are going to talk about some countries that make this kind of things. So first is Australia. Australia was interested in smart grid since 2009 when they proposed to give a smart grid for all the community for the winter of 2010. The government was interested to raise awareness in consumer about energy utilization and establishment of distribution demand as well as generation management systems. Another project was launched for testing network fault detections, insulate and restoration power quality monitors, and automatic distribution of electric power by distribution manager systems. Canada, the government of Canada make a mandatory of installation of smart grids for business and households in Ontario in 2010. Federal government also took different initiatives like clean energy and eco energy innovations. Currently, different pilot projects in province of Quebec and Ontario are going on. Actually, the National Smart Grid Technology and Standard Task Force was created to fund a development of all aspects of the smart grid. England, in other hand, is one of the biggest producer of energy from protovoltaic, low carbon. London institution increased a number of technology like protovoltaic, smart meters, electrical vehicles, and heat pump with distribution systems to reduce carbon emissions. The warfare cryogenic energy stores solution was implemented in England too.
China's government is more focuses on the policy related to conservation, encouraging diverse development, protecting environment, and relying on domestic resources. That is why development is in smart grid is on the priorities of Chinese policy. Chinese government is more focuses in United States of America to be a proliferation for the smart grid development since early 20th century. National Institute of Standard and Technology will be responsible for looking after the development and modernization of grid and form a commission to access its benefits. A full meriting system with consumer with web portal and automatic notification feature was developed by Houston's Smart Grid. On Europe, in early 2005, European Union formed a European technology platform for the development of smart grid technology. Portugal did a real-time implementation of managing and control system of smart grid in a pilot project. Italy is playing a vital role in research and development of smart grid. University of Genoa is working on mathematical modeling of optimal operation for power generation microgrid, which is stepping stone towards a large scale mirroring. Okay, for future research in smart grids and recent trends. A lot of research is undergoing for the development of smart grids. Still a lot of potential is available for future research for different aspects in different areas of smart grid. This includes the area of forecasting, power flow optimization, communication, microgrid integration, demand and the energy management systems, comfort of standards for interoperability, scalability, economical factors, data, encryption, and most importantly, automation of generation, transmission, and distribution. Research of and managing on the smart grids have been seen tremendously increase in the last decade. This this is why smart grid technology has been shifted from virtual reality concept to implementation phase. There was tremendous incrementation in the research in the last 5 years. In smart grid, well, of shown in figure 5. In smart grid and sun, this will be game changer in electrical power distribution with more flexibility and efficient ways. Mm. For conclusion, advancement of technology and device can change the utilization of energy in an economic and environment friendly way. Evolution of a smart grid concept has a potential to meet all the future needs of utilization of energy in the best possible manner by reducing carbon emission and integrate with a more renewable energy mix. Government policies are needed to facilitate smart grid implementation. This article points out the need of the modernization of conventional grid and how researchers are implementing a smart grid concept for electric power distribution networks. It is still difficult to predict how far the region in smart grid is required to fully implement this concept, but recent research like smart meters, demand side and managed system, self-healing and big data and are a source of encouragement in smart grid technology. Okay, this is our reference and thank you.